We worked really hard to find that formula down in the bottom right-hand corner for the nth partial sum of an arithmetic sequence. So let's put it to some good use. So we're asked here to find this partial sum, 5 plus 9 plus ... up to 41. And this is the partial sum of an arithmetic sequence. And we can tell that because we get from one term to the next by adding 4. So let's copy down our formula for the nth partial sum of an arithmetic sequence. We got n times a1 plus an, all divided by 2. So in order to use this formula, we need to know 3 things. We need to know a sub 1. That's easy. That's the first term in my sequence. That's going to be 5. We need to know an. That's the last term in our partial sum. That's also given to us for free. That's 41. The hard part on this one is going to be to figure out what n is equal to. So that's how many terms are in your sequence, which is not obvious because I've got that ... in the middle. We need to figure that out. So I could just brute force this and figure out how many terms are in the sequence. 5 plus 9 plus 13 plus 17. We're adding 4, so let's just build this. Plus 4 would give me 21, plus 4, plus 4, plus 4, plus 4, plus 4. We figured it out there. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. So n is equal to 10. All right. So you could do this every time, but if I give you something that's bigger than 10, like 100 terms, you're not going to want to go through and do this every time, right? If you're going to write out 100 terms, it kind of defeats the purpose of having a shortcut formula. So how could we do this methodically? Well, we know that the common difference is 4, so we could just ask ourselves, how many times did we add 4 to get from 5 to 41? So to get from 5 to 41, let's see, that's 41 minus 5, gives me a difference of 36. That means that I added 4 9 times. And if I added 4 9 times, that means that starting off with the first one, I've created 10 terms. So we know that n would be 1 more than the number of common differences that I've added up to get to the end. All right, either way, we find out that n is equal to 10. I'm going to plug into my formula. I've got n equals 10, 5 plus 41 divided by 2, and that's going to give us our partial sum. So I'm going to do 10 times 5 plus 41 and divide that by 2, and I get 230. And a quick check on the calculator, if we just type in all of this stuff down here, will tell us that 230 is the right sum. Let's use our shortcut formula again on this one. This is an arithmetic sequence partial sum, and I can tell that because my common difference is going to be a negative 5 because I'm subtracting 5 to get from one term to the next. All right, so we know our partial sum formula is equal to n, a1 plus an divided by 2. Again, the a1 and the an are given to us for free in the formula. We start off with 20 and we end up with negative 50. So just like the last one, the hard part is figuring out the n, how many terms are in this sequence, since we don't know what's in that ... just by looking. So just like the last one, I'm going to subtract negative 50 minus 20, my end point minus my start point, and say, how many negative 5s have I done? So this is negative 70. And I'm just going to divide that by my negative 5. So negative 70 divided by negative 5 gives me 14. So this is 14 negative 5s. And just like the last one, we know if we're subtracting 5 14 times, that means we're creating a list of 15 numbers. So that means that my n must be equal to 15. So let's plug this in. We're on S sub 15. 15 times 20 plus a negative 50, all divided by 2. And we'll go to the calculator to see what that is. And I get negative 225. And again, if we were feeling very thorough, we could go list out all the numbers in that sequence and add them up and get negative 225. Last example, using our partial sum formula for an arithmetic sequence. This one, you could just go ahead and expand that summation notation that they've given us, figure out what k equals 1 through 12 is equal to, but we'll try to be a little bit more sophisticated about it. So we can know for sure that they're asking us for the 12th partial sum. So unlike the last two, finding out n is not the difficult part. So we've got S sub n. I'm going to copy down my formula as usual. For free, this time we get that n is equal to 12. We're looking at the 12th partial sum. The hard part, which is not really all that hard, is that we got to figure out the a sub 1 and the a sub n. A sub 1 is pretty easy. We're just going to use this formula to figure out a sub 1. That's just 3 times 1 minus 8. It gives me -5. And then we need the nth term, or in this case, the 12th term. So just use the formula to plug it in. The 12th term is 3 times 12 minus 8. So it's 36 minus 8, which is going to be 28. All right, so our a sub 12 is equal to 28. So let's just plug in. So we've got our 12th partial sum equals 12 times -5 plus 28, all divided by 2. Plug it into the calculator. We get 138. All right, so that's our last one for partial sums of arithmetic sequences. We'll talk about a shortcut formula for partial sums of geometric sequences whenever we meet together in class.